So, dear colleagues, do you hear me? So, dear colleagues, please write some information if you're here. Yeah, okay. So, I'm not sure about the quantity of students that's now online. One, as I see here. So, I think we will wait the other guys. There's no problem. So as you can see, here is a demonstration of my screen of my computer, and you can see here the presentation. So first of all, I want to start talking about our next steps of conversation, of cooperation in the frame of this situation. So we will work over the internet, online, and I suggest that we will organize our meetings over YouTube, Skype, and other technological systems that we can provide each week, because including the situation that we are skipped to Fridays with our lessons. The first Friday that we are skipped was the Friday when you decide to leave the Russia, but the second one is connected with 1 week that we are skipped to. So we have to compensate these lessons, and of course we will find enough time to organize our lessons and to put our attention to necessary material of our discipline. So today I want to organize our meeting maximum 40-45 minutes, because I don't think that is good idea to demonstrate to you some videos over YouTube, because YouTube you can use to find the videos. So our meetings will based on using your possibility to find some information, and I prepare to you some information. There are two files. Hello guys. There are two files with presentation. At the end of our stream I will put the links into the chat and you can use it. So the first step is to discuss the main aspects, the main theory of material treatments, blah blah blah. So we already done it, and I've got the short presentation with this this presentation. You already got it, and I will send you the link to download it. So we'll skip it now. Next step, it's to use some list of useful links to the video content in the YouTube, and I've prepared this useful links. No, sorry, it's not this one. I will send it to you, of course, over the chat, at the final stage of our meeting today. So you can see here there are a lot of useful information about the materials, about the metallurgical processes, about the processes connected with processing and treatment of materials. So one link to the YouTube channel with a lot of interesting video, so I will send it to you later. This is your homework or your home task for your education, because as I understand now you've got enough time to investigate something new in internet, and of course connected with your studying here in Magnitogorsk. So of course after our overview today, our topic, I will send you the additional links connected with today meeting. I prepared it in the file too. I will send it later. And as you can see, I've got a presentation on in two languages. One language is your language, it's in French, and the second one is the language is English. In English, so of course we don't need to use the Russian in our situation. So as you can see, the main idea of this presentation is the classification that presented at 5 slide. So you can personally read these slides. I will send you the links with PDF of this presentation too. So today I want to talk more about this classification. This is a classification of processing modes, processing regimes of material. Mainly it's metal material, metal alloys, and of course it could be any material that you want to process, to modify, and of course each of this type of classification got a personal specification, advantages and disadvantages, of course, the area of application, some specific, and today we discuss two points of this classification. We start from the left to right. It's electroerosion and electrocontact treatment and processing. So here you can find the slides with explanation of these processes, and now I will start to explain you some basic moment of these technologies using some material from internet too, and main attention that you have to put on in our lessons is your personal work, because a lot of material that I've found in internet for you, you can see the videos, you can read some links and articles. So my main hope is your personal work, because we've got this classification, we've got the standard technology that we use today, short of review for each other, and according to this classification we try to go step by step for each points, and finally we discussed all these points, and of course you have to find the time for now it's not so hard to work hardly in your personal option according each point. So I just only explain some things connected with the 2 points. So let's we start about electroerosion. So you can see this is a method of material treatment that we can use using chemical reactions between the instrument and material, between the workpiece and material, and you can see that we can use the different power. The power now here is presented in volts, so we can use different frequency of electricity. So how does it work? This is the main question that you have now, as I understand. Okay, the main idea, let me explain you, let me show you. The main idea of this method is I use the link, so because I want to show you some material from internet. This is a good explanation of this method that can
Understand how EDM
that we discussed. So let's start. Let's have a look a short video. So sorry, I've got to find the option. Okay. This is a video about this method that we discussed now, electroerosion. So
As erosion continues, the machine controls advance the electrode through the work, always maintaining a constant gap distance between it and the workpiece. To understand how EDM removes metal, let's examine a single spark in the erosion process. As a pulse of DC electricity reaches the electrode and part,
so you can see here the scheme of the process. So you can see two electrodes with a different charge, the plus and minus, and short explanation how does it work.
an intense electrical field develops in the gap. Microscopic contaminants suspended in the dielectric fluid are attracted by the field and concentrate at the field's strongest point. These contaminants build a high conductivity bridge across the gap. As the field's voltage increases, this material in the conductive bridge heats up. Some pieces ionize to form a spark channel between the electrode and the workpiece. At this point, both the temperature and pressure in the channel rapidly increase, generating a spark. A small amount of material melts and vaporizes from the electrode and workpiece at the points of spark contact. A bubble composed of the gaseous byproducts of vaporization rapidly expands outward from the spark channel. Once the pulse ends, the spark and heating action stop, collapsing the spark channel.
So you can see the removing of the some parts of the workpiece using the spark between two electrodes. So in this case we use the method. Of course we have to realize this technology in the frame of specific protecting shield, protecting you can see here in oil. So it's one of the type of processing that we can called electrocontact. Sorry, I start from electrocontact, not from the electroerosion process. So a little bit later I show you how we can use it to processing to modify the shape of the material to obtain necessary and sometimes very hard and very complicated forms.
Dielectric fluid rushes into the gap, flushing molten material from both surfaces. This EDM residue consists of small solidified balls of material and gas bubbles.
So this is a short overview of the this process, and next video we have to look so I'm not sure about the sound. So you can see here a lot of final products with a very hard and complicated forms. It's very hard to obtain these forms using traditional methods that we discussed before, and in this case we use EDM machine that we saw before, and this is a short overview, and I want to, after this overview, to give you some additional info.
Parts with highly detailed, extraordinarily tough shapes and tight tolerances can be nearly impossible with conventional machining techniques, but not with a wire EDM process. Imagine being able to make precise cuts in metal with a blade no thicker than a human hair. That's what wire EDM can do. EDM stands for electrical discharge machining. But instead of a blade like a bandsaw, wire EDM uses an electrically charged hair-thin wire to remove microscopic particles and shape the part. These animations help show how wire EDM works. The wire carries one side of the charge, conductive material carries the other side of the charge. And when the two get close, a white-hot electrical spark jumps the gap, melting away tiny dust particle-sized pieces of metal, 2 microns or smaller. How small is a micron? Well, if this was the diameter of a human hair, this would be a micron. But what's all this liquid? Well, that's the dielectric. Deionized water, really, useful because it doesn't conduct electricity. In wire EDM, the liquid dielectric controls the sparking, cools the process, and flushes away those tiny particles as they're removed. All very fast, about 1 million sparks per second. The particles themselves are each about the size of a particle of smoke. In the right hands, wire EDM can be used to hold really tight tolerances, create incredibly complex shapes, work with difficult materials that may be extremely hard or soft, and if needed, make really, really small parts. There's even something called small hole EDM for working from the inside of the hole to the outside. All completely automated and CNC controlled. No human involvement. At Exact, wire EDM is all we do. We're very good at it, making us the perfect wire EDM partner to produce complex precision parts that often can't be made any other way. Like this. Looks like one part? It's really 2. And this springy thing is just one part. Want to see more? Watch more of our videos or call for an appointment. You've been watching how wire EDM...
So this is one of example. So you can see it's electric contact process. That process is described here on this slide. So now I can give you some little short explanation, and we will back again to electroerosion, of course. So electrocontact. So EDM principle is using the instrument and workpiece to remove the workpiece element, the parts of workpiece, according to the necessary shape form. So as you can see, this is a electrocontact treatment cylinder, for example, as an example. So this slide is for next explanation. And this is a very useful method to produce some parts and elements of parts um, for different application for different machines, small parts, and as you can see before, they in previous video they use the some specific wire that provide sparks to remove the necessary material elements. So in this case you have to know the form of your instrument. For example, we can I want to show you some things that I got. So if this is a workpiece, for example, and this is an instrument, you have to understand that the sparkle will providing here, and for example, if this instrument as a wire, as in previous video, the sparks will appeared here. So according the form, depending on form of instrument and the form of contact, you can remove some elements from the piece, and of course depending on this instrument you can get some limits of final shape of the workpiece. So as you can see in the video here, this is some elements with some symmetric forms as a final product.
Highly
Okay, we can find it here, and of course it's impossible to remove some inside of this cube, for example, some elements, and it's very hard to organize the removing of some specific shape with for example, you need to remove from surface some screen, something like this, and you have to use the necessary shape. This is the same of the instrument to organize the sparkle here. In this case, of course, we've got disadvantages and advantages of this method. So EDM, I can show you some more additional information. EDM got some limits to use this technology. This is one of example again. This is a spark erosion.
Мешают спам-звон?
This is it. We have to wait some periods for this. As you can see, this is a very precise technology. You can produce the necessary so let's have a look at a specific machine. This is a spark erosion machine that we can use to processing and treatment of the some metals. So of course I skipped the main information connected with of course we have to use the metal as electrodes to provide the electricity, conductors and something like that. I skipped all this information because it's obviously understandable things, main requirements of course, and so let's have a look how does it work, how work this machine. This is a machine with the instrument, with the liquid, and work of course with dielectric because as we discussed before, as it was shown before, we have to remove the heat, we have to remove the elements of material. Some elements of material will stay in this liquid, and so you can see this is a copper electrode that we use to form the workpiece. Skip this. So now we can start the process. As you can see, the sparkles. This is a little sparks. So a short explanation about the precision. This is how this information about the quality that you can provide, the quality of the process you can provide to remove some microns of material from the workpiece. So we can skip this processes, and as you can see, we used the electrode and workpiece, and you can see now how we obtain the result, because before you see this is elementary parts of mechanism and machines. So sometimes it's if you want to remove the very small layer of material, you can use this method. Okay, the 27 minutes we already used of our short lesson, and next method, electroerosion. So we can see another one, EDM method. Sorry for this. EDM method to drilling. This is a short overview too. This is as you can see, it's mainly
hole drilling machine, and behind
advertising
it
video.
and you'll see some of the other machines we have here at our facility. Small here you if we look at electric
Let's
energy
start
between the electrode and the workpiece until it gets
see
high
how
enough
does
for a
it work.
spark to jump across and erode material.
This instrument, this is a workpiece, and this is a area of contact. So this is one
Bottom
example.
hole to a set depth is required.
You can drill the small
Here you can
holes,
see the electrode being eroded, but the part isn't, and that's making
and you can see the moving the electrode from the billet, from the
the
workpiece
electrode flat again.
through the billet.
Depth sensors. The machine has a function which calculates the wear of the electrode during drilling and resets the depth accordingly. Thereby the correct depth of hole is achieved by compensating for electrode wear.
So let's have a look at the final result. You can drill the necessary holes during over the, it doesn't matter how thick the material, because anyway you can drill any holes, and with a high precision. High precision, as you can see in the previous video, you can obtain up to several microns, and sometimes it's very good result. So you can think why we should use this method. The main advantages of this method, because I don't want to discuss all of them, it's the possibility to remove some material with a high precision, because in this case you will obtain the very precisely form, and you can obtain the part with very strong requirements to their sizes. So you can't do it using rolling, forging, dyeing, cutting, welding. It's impossible, because in this case you don't obtain necessary precision. And of course, in this case you use the high temperature. As you can see here, you can organize the moving of the liquid to remove any high energy and high temperature, and to avoid any modification connected with some phase and structure changes into the metal alloys. So as a result, I give you the link. You can hold this video. You can hold this video later. So as a result, it's a very good method to obtain the parts with high precision sizes. So let's have a look at the next one, the electro-erosion treatment. So unfortunately I completely don't understand nothing in your languages, sorry, because this presentation was made by my colleague, by the other professor, and I've just added the English information here, and I try to checked the French phrases into Google Translator, and sometimes sorry for my misunderstanding on some mistakes connected with some specific terms that I've used here. So okay, let's have a look at the electro-erosion treatment of metals and alloys. So let's start from the main aspect, of electrochemical machining. The main aspect is quite easy to understand if you look here into this video. This is a short video. I can increase the speed, so please keep in touch to have a look at this video. I will stop the videos and try to explain some additional information.
ECM is an advanced, extremely accurate metalworking technique based on electrolysis. ECM, electrochemical machining. Through the use of electricity and chemistry, metal is machined in a non-conventional manner, in which the metal is quickly and accurately eroded to produce the desired three-dimensional end product. We call the tool that is used to machine a product via ECM an electrode, or cathode. This electrode has the inverse form of the desired end product and does not wear during the process. The material used for the electrode does not have to be harder than the workpiece either, because it makes no contact with the workpiece, electrically or mechanically. The metal workpiece in its raw form is eroded via an electrochemical process to achieve the desired end product. To illustrate the process, We show a cross-section of the process at the point where the process gap, and therefore the resistance, is lowest, causing the material to dissolve anodically. In the process gap, which locally is smaller than 10 micrometers, the metal on the anode or the workpiece will dissolve quickly and accurately. The released electrons will be used at the cathode for the corresponding reaction. This corresponding reaction may consist of splitting water into hydrogen gas and hydroxyl ions. The dissolved metal ions can combine with these hydroxyl ions to form metal hydroxide. These reaction products, metal ions, metal hydroxides, hydrogen gas, and heat, are transferred by the electrolyte at a speed varying between 15 and 50 meters per second. The electrolyte can be reused indefinitely due to the use of high-quality filtration and cleansing techniques. Electrochemical machining can be used to process virtually all metals and alloys. The speed of the process is not dependent on the hardness or toughness of the material, which means that exotic or hard alloys and hardened steel can be dissolved just as quickly as a soft material, like aluminium. The product features high accuracy and surface quality and is completely burr-free. The product is machined without any contact, so the product is not subjected to any mechanical stress, nor is there any thermal stress on the product, so no heat-affected zone develops. Furthermore, there is no mechanical or thermal load on the tool, so there is no possibility of wear. ECM, electrochemical machining.
So this is a short overview, and as you can see, I just try to compare these two methods, if you don't mind. The first method, electrocontact, connected with this is a good explanation video too, how the electrochemical machines work, ECM. I can add this video to the list that I'm sending to you too, so it could be useful. Sorry, main aspects. So let's try to compare. The main idea in the electrocontact method that we discussed before, it's to remove the part of workpiece. But here in this method, you use the arc charge, and that means even in the case that we use the liquid to remove the heat, some piece of material will contact with this arc charge. So that means you will obtain the surface with this arc that contact with this arc charge. So in the case of erosion method, ECM, you don't need to organize the contact, because in this case all of your material will removed without any contacts, without any heatings, just using the electrochemical reactions. So let's have a look at another one. Another one thinks sorry, this is a for with later P. It's mean that you have personal education, you have to look at this. So we will try to find the difference between these two processes, mostly in the fact of contact with directly contact with the workpiece, and in the case of ECM you don't get it. And in this case you can modify any material, and as you can as these guys told you now, you will obtain the material very quickly as a final product, and it's independent of the properties of this material, because the ECM methods helps you to obtain the material independent of the hardness, of the mechanical properties, and something like that. So I think when we will finish our course of our discipline, you will understand why some mechanical parts it's so it costs so much. It's why some parts is so expensive, because you have to spend a lot of times, and you have to use the very expensive machines. You can see these machines, and these machines is very expensive because you have to control these processes. It's very modern processes, and of course in the final thing you will understand why some parts is so expensive. So, and if you compare this, if you assemble the final mechanism from these parts, of course you will understand why some mechanism it's so expensive too. For example, why the engines for cars it's so expensive, because in the, as I remember, in standard cars that we used every day, we've got about 800 moving parts, and just to imagine that each parts have to follow the necessary requirements according the sizes, and we have to use some methods, something like that, something like these two methods, some like these two methods to obtain these forms. So that's mean using this information you will more clearly understand some technological processes in the future. So now I will give you the links that I promised before. This is the links with the based theory that I send you here in the chat. Sorry, but the program tells me that impossible to send this so huge information stream. So okay, I will give you only one link that you can use a little bit later, because now I've got only 2 files with this link, and sorry, I have to find this link. Okay, you can see here this link. I will send you this link into your into the chat now. It's easy, so you can use this link, this one, to find 2 files, and I will put right now after end of our stream here 2 files too, with links to the videos, this one and this one, so you can download it later. So here you can find the presentation of main idea that we're talking before in previous lessons, and this is a part of this presentation. This is the first 8 slides of contain this classification tool that we discussed today, and you can read it more carefully, and please if you don't mind, we will organize the same stream next Friday according our schedule that we've got, because according our schedule, as I remember, we've got something like this. According our schedule, next week we will work in this time, and if you don't mind, we will organize the next meeting next Friday. Later I will send you the info about the time. Maybe we will start in 12, and we will spend the same time that we spend today. I explain you why not. We will not talking with you during the 4 hours, because it's impossible to organize your concentration of your mind during whole this time sitting near the monitor, and so that's mean I've planned spend the time during the traditional full contact lessons. I've planned to use this video that I've showed you before, but with a lot of examples, as you can see here. So you can do it by yourself, and we don't need to spend the full times lessons, but we will organize it each week, not only once in 2 weeks, but we will organize it each week, each Friday. As I can see, this Friday you will get the free time up to 14:00, and next Friday we've got lessons. So one Friday we can organize our lessons in 12, and next Friday, like today, we can start the same time. So that means that we will meet every week. So please feel free to prepare your list of questions, and next lesson we can start from discussing your questions connected with these methods. And I think that we will start to talk about your personal homework when we come here, something like that. And here we're start talking about your homework for each of personally for each student. So if you got some additional questions, you can write me over email, over the Skype, over the our social networks like VK, like Facebook. So you can find me anywhere. So it's maybe it's more convenient to you to use a traditional email or Skype. That's no problem. What about the Skype? I'm not sure about other guys. This is my login in the Skype. You can find me, and please feel free to ask any questions. So if you don't mind, we will finish. We finished today. And thank you for coming, thank you for watching. You can back to the watching of this video a little bit later. I'm not asking to you to press like and something like that. It doesn't matter, because we use this technology only for education. So thank you, and we'll be in touch. See you next week. Please prepare your list of questions. Thank you. Bye. And I end my stream. I wish you luck, and stay healthy. Stay safe. Bye.